So we are going to look over an exponential growth problem. This example's in about population in Austin, Texas. So this is the scenario we have, and you're given an equation that represents population. This number, let's see, this number right here is the starting population. This number in the parentheses is the growth factor. All right, so the first question asks if this model represents growth or decay. It is growth. The reason why is that the growth factor, so that number in the parentheses, is larger than 1. That's how we know it's growth. We want to next identify the annual percent increase. I'm underlining increase because if it's growing, it's increasing. The way you do that is you take your growth factor. So our growth factor was 1.03 and you subtract 1. And when you do that, you are left with 0.03. To turn that into a percent, you are going to move your decimal 2 to the right. So this number as a percent is 3%. So the 0.03 is the rate as a decimal, but it's actually 3% if we're asking you for a percent. The last question here is what's the population in 6 years? So basically what I need to do is write my equation. So I'm just going to write this equation down. I have, 49429. So 494.29. Then 1.03, and then t. But instead of t, I'm going to do 6 years because t represents time. So that's my t, and I'm going to put this in the calculator. So let's do that right now. We have, I forgot the number already, 49429. 494.29 times 1.03 to, instead of the t, we're going to do to the 6. And that is what the population will be in 6 years. 590, we'll say 590.21. 590.21. And this is actually in thousands. So that is how you do these kinds of problems, the exponential growth problems.